who's going to talk about the modern cloud data warehouse, Snowflake on Azure. It's all yours.
All right, thank you for the very short introduction, Daniel. So welcome to the first session of GroupBy in the European time zone or African time zone. And the title of my session is The Modern Cloud Data Warehouse, Snowflake on Azure. So it's gonna be an introduction to the Snowflake data warehouse. So it's a cloud data warehouse specifically built for the cloud, so you don't have it on premises. And it's a third-party provider, so it's not Microsoft, it's another company, and they provide their services in Azure, but also other cloud platforms, so as AWS or Google. So why would you attend a session like this one? Well, in the recent years and months, Snowflake has been growing very rapidly, and they have been taking customers from Azure SQL Data Warehouse or Azure SQL DB. So if you want to compete against them, then maybe you should know a little bit about them. So it's one of the reasons you can attend this session, or just try to learn which are the directions cloud data warehousing is going to be in the coming months. All right, so very short bio slide. So my name is Koen Verbeeck. I work as a senior business intelligence consultant for the company AE. I have my own blog on sqlcover.com. If you have any questions, you can ask them, and then you will group them, and they will ask me at specific time intervals. Or you can just ask me after the session on Twitter, or you can contact me through LinkedIn or post something, a comment on my blog. I'm from Belgium, which means it's the country of beer, it's the country of French fries, and also the country of the best chocolate in the world. I'm not sure Daniel will agree, but we say it's the best in the world. All right, so let's see what we're gonna talk about today. So I'm gonna give you a short introduction to the company of Snowflake. I'm gonna talk about its architecture. We're going to talk about a feature called time travel. We're going to talk about how you can set up sort of a typical data pipeline scenario. We're going to talk about some cool stuff in Snowflake. The pun is intended. And at the end, I'm just going to wrap everything up with a conclusion. All right, so let's start. Okay, what is Snowflake? So I warn you, there are some marketing slides that I got from Snowflake. I'll go quickly over them, but the thing you'll see is all very fluffy. So take it with a bit of grain of salt. So it's a relatively new company. It's founded in 2012 by some people who were not happy with the way things are in the cloud. So they founded their own company to start a company that builds a data warehouse specifically for the cloud only. And they have been growing rapidly. They started on AWS and then they moved to Azure because guess that some retailers apparently were not too happy with Amazon, and they said, okay, we want to work with Snowflake, but not on Amazon. I say, all right, let's do Azure instead. And in recent years, they've also moved to the Google Cloud Platform. So they're growing very rapidly and they've been adding features non-stop. All right. So they say, okay, it's a database, it's a SQL database in the cloud. So it's a normal SQL database, it's a relational database, but it's really meant for data warehousing. I will repeat it, and maybe I'll repeat it a couple of times throughout this session. It is not a transactional OLTP database. Do not use it for that. Do not use it to power up your application or whatever. It's a data warehouse, and use it for data warehousing only. But it supports SQL. You can just write a SQL that you and I already been writing for years. There's no knowledge that you need to learn. You can reuse all your SQL knowledge in Snowflake, and all of the tools, most of them at least, will still work with Snowflake. If you use Tableau or Power BI or Talent or whatever, you can still use it with Snowflake. There are integrators and connectors for a lot of those applications. All right, so their main selling point of Snowflake is it focuses on the data and not on the infrastructure, so it's zero management. You don't have to do anything. To have to work with Snowflake, you go to the Snowflake website, you fill in a form, you get a free month, a trial month, let's say a couple of $100 in credits, and just start. So they set up everything for you. After 15 minutes, you get an email saying your environment is ready, you log in, and you can just start loading data, writing SQL, and do the stuff you like doing. You don't have to spend any time setting up servers or configuring a VPN or stuff like that. It's zero management. Unfortunately, it also means zero options. If it goes wrong in terms of performance, there's not that many you can do to fix it. So there are no indexes, there are no distribution key, there are no partitioning or vacuum that you can use to improve performance. it's there. There are partitioning, so the data is partitioning like column store indexes, but you cannot influence it, or very little. So there's not much you can do if things go wrong in terms of performance. So it can contain all of your data. Again, it's a marketing slide. So you can import JSON, XML, Avro Parquet, other types of files, and they have specific structures in SQL to deal with those kind of files. So they have arrays and stuff like that. And it can scale up to multi-petabyte scale. It's quite fast out of the box. All right. And it supports all of your users, of course. So they say, okay, it's very fast and consistent SLA, everything is secure, and you can have multiple applications at the same time, and they don't impact each other. All right, so this, again, very short introduction, marketing slides. Now let's take a look at the architecture. So it's a multi-cluster shared data architecture, which means you have the bottom, you have the data storage, which again is built specifically for the cloud. So in Amazon, for example, it's S3. On Azure, it will be Azure Blob Storage. And at the top, you have your cloud services. So this is the brain of the system, and it manages everything. So you have your optimizer, you have a transaction manager, you have something that manages security, like authentication, authorization. You have a metadata layer, which keeps track of everything that is going on in Snowflake. If someone runs a query, it keeps track of, okay, what is this query? We executed the query, how long did the query take, which tables did it read, and so on. And this is important for some features that I will introduce later on. So if this cloud service is the brain of the system, then you also have the virtual warehouse, which are the muscle of the system. This is your compute layer. So they're elastic virtual warehouse, and I will go in depth on what this exactly means. Right now, you just need to know, okay, you have multiple warehouses, they have a cache of the data, and it will process your data, but the data itself is stored in the lower end data storage, which is some sort of hybrid columnar storage. So it reminds me a little bit of column store index. It's not exactly the same, but generally speaking, it's about the same thing as a column store index in SQL Server. So columnar and with partitioning that can be eliminated and stuff like that. All right, so I mentioned there's an optimizer. I'm not going to go too much detail in that. So it's a top-down cost-based optimizer. It's basically the same you have in SQL Server. You write a query, it will go over the query and try to find the optimal path to run that query as fast as possible. But you don't have any influence. There are no query hints. You cannot tune your optimizer. There's nothing there. It supports most data models, but Snowflake themselves, they say, okay, star schemas are the most optimal ones. So you can write third normal form or even data vault, but it's optimized for star schemas. Okay, we have the metadata service, which I mentioned earlier. And this is a foundation for a lot of features that are running in Snowflake. And one of those features is pruning, which I will come back to. Also time travel, zero coupled cloning, and data sharing. It scales linearly. So if you have more users and more stuff going on, it should scale at the same level. So it shouldn't become a bottleneck. Right, so I mentioned a couple of times that there is pruning. So if you write a query, it will access only the data that is needed, just like with a column store in SQL Server. So let's, for example, we have a table. It's been a while since I created this slide deck. So it's June 2019. And let's say, okay, I only need data from the 9th of June 2019. So the ones in dark blue, that's the data that I need. And the ones in light blue are not the ones I need. So everything is partitioned in this case on the day level. And when I execute my query, it will only read the partitions that I actually need for my query. So there are no traditional indexes. There's no column store. There's no clustered index, no non-clustered index. Those concepts do not exist. They do have foreign keys, but they're not enforced. They're like sort of documentation purposes. Yeah, I see some people, oh no, yeah. The main response when you ask about this, it's the goal of the ETL to enforce your relational integrity. So you can define primary keys, you can define foreign keys. They are not enforced. They're used for tools like Power BI. So when you read out your data model, then Power BI can more easily automatically create relationships using that metadata, but it's not enforced. Anyway. So it will automatically prune your data, only read the data that you need using min, max values, distinct values, and null values, for example. All right. Sorry for the bad pun. So as I mentioned, it's a fully ACID compliant database. So you have transactions, you have concurrency control, it's fully ACID compliant. And each time you do some sort of modification to a table, it will store this table as a separate copy. So you have multiple versions of the same table. And this is because cloud storage is immutable. You cannot change it. You cannot change a file, you cannot modify it. If you do this, it will actually create a new version behind the scenes and it will keep the old version behind. It's also sort of like a version control system. And it does this with tables as well. So every time you do an insert, an update or delete or truncate table, you'll just create a new version of that table. This is very important for later features that we will discuss. All right, let's go to virtual warehouses, which I think, in my opinion, is one of the killer features of Snowflake. And you see a t-shirt over here because the size of such a warehouse is expressed in t-shirt sizes. So the smallest size is an extra small. And you can imagine, okay, this is a little virtual machine running somewhere in Azure Compute or in whatever. And it has a little bit of RAM, it has a little bit of CPU. It can have some data in cache as well. And this is an extra small. This is your smallest unit of work. And I have to say, out of the box, it performs quite well. Just because of the way the data is structured and compressed, you can already process a couple of gigabytes of data fairly easy with a couple of users. Now, if you go to the small warehouse, it doubles in size. And then you go to medium, you go to large, you go to extra large. And then you know it's an American company because they also double times extra large, 3 times extra large, and 4 times extra large. So you can easily scale up and you can scale up a whole way up. So very large, but this will also cost a lot of money. So a virtual warehouse is the compute engine of Snowflake. It's where queries are calculated, where the results are calculated and sent back to the user. And you can scale up or down as you need to. And it's very fast. It's almost instantaneously. As a user, if someone of the admin team scales up a warehouse, you probably won't be impacted. Your queries just keep on running and you won't even notice it. It's pay-per usage. So for every second you use a warehouse, it's computing something, you will pay. So the first minute is always an entire minute. And after the first minute, you pay per second. You can also configure auto suspend. So if the warehouse has not been used for a certain amount of time, it just automatically pauses itself and then you stop paying for it. You can also configure auto resume, which might drop the cache. So it can be a little bit dangerous. Which means if a warehouse is idle and someone just starts querying, it will kick off again. Again, lightning speed, you won't even notice it, maybe less than a second delay, and it will just keep on resuming and calculating and you start paying again. And you can script everything through SQL or other interfaces. So for example, at the start of your ETL, you can say, okay, this warehouse, double it in size, and then you crunch all of the data in your ETL, and then at the end, you just reduce the size again. If someone would use a warehouse, it's cheaper. The big advantage here is if you go up in size, it's also faster. So your ETL finishes faster because most of the queries will be done more quickly, which also means you pay less. So you have to find the optimal balance between a big enough warehouse so your ETL finishes as quickly until you reach, at some point, you will reach some bottleneck that is not your compute, probably storage or IO or something like that. And then if you go up, you will start paying more, but the calculation time will not be reduced. So then you go down and then you find this optimal point where you say, okay, I have a good warehouse and this is the short amount of time that I can get with this warehouse. So there's a little bit of balancing that you can do, but it's a great notion and it scales almost linearly. So if you say, okay, I have a query that runs for 10 minutes, if I go up one size, it should be finished around 5 minutes. So you pay the same amount, but the query is finished in half its time. I say somewhat linearly because there are other bottlenecks than just compute. All right. This is scaling up and down. You can also scale out. So let's say, okay, I have a lot of users, but they just run queries that are not that compute intensive. There are just a lot of them. So they can swarm a single compute warehouse and say, okay, it's not computationally intensive. There's just a lot of them. Then you can say, okay, just create multiple warehouses. So you can have one logical warehouse, but beneath the covers is actually multiple warehouses which are clustered together in this one logical warehouse. And then you can use it to load balance your users and your query concurrency over these multiple warehouses. And you can go up to 10. And this logical warehouse can be resized, suspended, and resumed as well, just like a normal warehouse. You can have auto scale possible. So just say, okay, we start with one, and if demand goes up, then just add extra warehouses to my multi-cluster warehouse. There's also some sort of an economy mode available. Say, okay, you can scale up automatically, but not too fast because I don't want to pay a lot of money. All right. Another great feature of warehouses is that you can use it for cost allocation. Let's say development, we crunch a lot of data while we are creating our data warehouse. We need a big warehouse. Then we have the ELT or the ETL or whatever data pipeline. This crunches all of the data during this batch hour. All right, we need a very fast and very good warehouse to finish this quickly. Then you have finance. Okay, there are a couple of users, but for the end of month reporting, they maybe need a little more, so you can configure like a multi-cluster warehouse. So if they need more computational power, it just automatically scales. And you have marketing, there are lots of people, but small queries, so you can assign, again, a multi-cluster warehouse, but with smaller warehouses for the marketing department. Now, the great part is your costs are allocated through your warehouse because every warehouse runs and for every second you pay. So you know exactly how much ETL is costing, you know exactly how much development is costing, and you know exactly how much marketing is spending. So you can say, if you really want very fast reporting, then you're going to pay for it. If you can say, okay, we don't have that kind of budget, then we give you a little bit of a smaller warehouse and you have to wait a little bit longer for your queries to finish. So this is something that you can do. All right, so you have the credit consumption. So for every second you're running, you have to pay. If a warehouse is running for an entire hour and you have an extra small warehouse, you pay 1 credit. So what is a credit? It depends on your licensing. So if you have an enterprise licensing, you will pay about $4 per credit. So running an extra small warehouse for an entire hour will cost you $4 or €4, so to speak. For storage, you pay, depending if you have pre-allocated storage or just storage on demand, you pay something between $25 to $40 per terabyte per month. So storage is actually dirt cheap. I think last time I checked, it was much cheaper than in Azure SQL Data Warehouse, for example. So storage is most of the time not your primary concern when it comes to cost savings. It's your compute that is going to cost you a lot of money, especially if you scale up and scale out at the same time. So I didn't fill in all of the numbers of the table, but if you go up to the right top corner, this is where you will be burning money. You can literally spend thousands of dollars per hour if you're not careful. All right, let's take a quick look at some demo. So so this is the user interface in the browser for Snowflake. All right, so when you log in as a user, you will see this. You have your Object Explorer at the left. You have your query window here. At the moment, there's no IntelliSense, there's no autocomplete or anything. They bought a company that should be able to do this, but they haven't integrated it yet. So it's on the timeline somewhere. Okay, you have IntelliSense over here, but right now you don't. If you really want this, just use another tool. For example, dbeaver is the one that we use at my client. dbeaver is free, it's open source, and it connects to Snowflake, and then you have IntelliSense autocomplete, all those features that you would like. All right, so this is my query. You can also check out databases, take a look at the warehouse, what is their occupation, or how much percentage is actually doing compute of that warehouse. You can take a look at the query history and so on. All right, so let's create this warehouse. So I'm gonna create a new warehouse here with the create or replace. I give it a name. I say, okay, it starts at extra small. After 60 seconds, after 1 minute, it will auto suspend. And I really advise that it's never below 1 minute, because if it's suspended too quickly, another user starts a query again, then you have 2 queries starting in the same minute, but you always have to pay for the first full minute. So that means within 1 minute, you can pay for multiple minutes. And this is not really cost effective. So make sure the queries don't suspend too quickly. Sorry, your warehouse doesn't suspend too quickly. It will auto resume if necessary. And the initial state is suspended, so it's idle. So I will create this, and you can see your warehouse over here. And if you click on resize, you can see all the different sizes and how much credits they cost. So it's suspended for the moment. So I'll zoom in a little bit. So you can see, okay, it's not live now. So the way Snowflake handles this, they have a pool of compute ready. It's already hot, and just waiting till someone says, okay, I need a warehouse, and they just swap in the compute. And this is the reason why it goes so fast. All right. Okay, so I just connect to my Stack Overflow sample database, another gift from Brent Ozer. So I loaded all of the data of Stack Overflow in Snowflake so I can run some queries. And now I'm gonna run this query over here. And this just says, okay, do not use cache, because the result set caching in Snowflake. So if you run the same query twice, it will just plug the result out of cache, which is very great, very fast, but not so great when we want to do performance troubleshooting. So you can disable the cache if you want to. So now I'm going to run this query. I think this query, I retrieved it from the Meta Stack Overflow website, where you can retrieve queries from the Stack Overflow data itself. So this query goes for a specific user, in this case, again, Brent Ozer, and it will check, okay, how many posts does he have, how many answers, how many unscored answers does he have. So the percentage is not that important. The only thing that it's important is that it retrieves one row for that specific user in about 16 seconds. So it does a self-join on posts. And if you go to posts over here, you can see it's a table of 20 gigabytes and 41 million rows, almost 42 million rows. So a self-join on 42 million rows. Yeah, filter a little bit here and there. 16 seconds on the smallest unit of work. I'm kind of happy with the results over here. But let's say I'm not happy and I say, I want much faster results. So I say, okay, make this a large, and it's already scaled up. You see, it's now a large warehouse. And then I run the same query again. And now it should be done much faster. At least that's what I hope. Otherwise, my demo will fail miserably. Right now, it finished in 8 seconds, which is a bit slower than I anticipated. Usually, it's around 2 to 3 seconds. But you see, okay, I just scale up my warehouse instantaneously, run the same query again, and now it's finished in about 50% of the time. So this is how the scale out feature works in Snowflake. All right, are there any questions so far on architecture Snowflake, on warehouses?
I can't see any questions right now. Let me just refresh here. Nope,
okay.
No questions.
All
so
right.
That means it's all clear as mud, I guess.
Yeah, explained perfectly.
Fascinating stuff, I must say. I just started looking at Snowflake myself at a client just a couple of weeks ago, and this actually clears up a couple of things. So,
all right.
Good job.
Yeah, I think warehouses is the killer feature of Snowflake because it scales up so fast and scales down so fast, and there's no interruption. You don't have to say, okay, the service is now temporarily down because I'm rescaling. No, just instantaneously, transparently, and I think this is the killer feature. And if Azure SQL Data Warehouse is one thing in the future, I hope it's this, that it scales up and down as fast as Snowflake. Right.
Yeah, I had no idea there were no indexes or stuff like that. That was completely new to me. That does explain a few things.
Well, out of the box performance is quite good. And of course, they have their own ways of making sure the queries are fast using that pruning, and they cluster the data and it's all compressed. But if it goes wrong, you don't have many options. It's typically, okay, you can specify like a cluster key. So you can say, I really would like that this table is now clustered on the date or on the customer or whatever. They say it's not necessary unless you go over terabytes or petabytes of data, then you can intervene and say, okay, maybe you should cluster it like this. Out of the box is not necessary according to support of Snowflake. But if a query goes wrong, just, okay, rewrite the query or split it up and use temp tables or stuff like that. I had to do
There
this.
is actually a question. Sorry.
Oh yeah, okay, yeah.
There is actually a question. So email asks, does it retain cache when scaling up, down? I assume no, since the demo query wasn't instant.
It's a very good question. I know if it suspends and then resumes, yeah, then it's gone. If you scale up, I'm not entirely sure. I don't know the answer. I have to look it up. But the reason in the demo why it didn't pull from cache is because I explicitly disabled it. And since I explicitly disabled it, maybe we can check it. Let's go to my demo again. So now I'm gonna enable my cache. All right, so let's go to the same. I'm just gonna recreate my warehouse so there's no cache now. And maybe I'm just gonna make it a bit large so we don't have to wait. So now I have a large warehouse, empty cache, and I run my query the first time. So about 4 to 8 seconds it should take. Right, so 8 seconds to run it. And if I now run it again, it's instantaneously. So now I know it's been pulled from cache. Right, now let's resize this. All right, so now it's a medium, it's still going. And if you now rerun the query, okay, it was very fast, so I assume it's from cache, and we can easily check this if you go to the query history. Again, a great feature. You can see all of the queries that you've been running. Oh my God, this is so useful for debugging. If you go, oh, I modified the query, but what was the query again? You don't have to Control Z till you found it. You can just check over here, you click on it, and you can also see the result set from that query that you run earlier. So you can always look up, oh, I ran 1 hour ago a query, what was the result again? Just look it up in the history, it's all retained. So if you go here,
I'm supposed to be moderating, but I'm actually learning stuff here. This is great.
Here you can see it returns 0 rows, sorry, although there is 1 row. So this is how you know it's from cache. If you have a result set, but it says 0 rows, then you know it's from cache. And this can mess up some applications, like for example, TM1 from Cognos. It reads the metadata first. Oh, 0 rows, there is no data. I was like, no, there is data, it's just from cache. So for that application, we had to explicitly disable caching. Otherwise, it just always said, oh, there are no rows, there's no data. Yeah, there is data, it is from cache. So to answer the question, yes, if you scale up and down, the cache is retained. It's probably only dropped if you recreate the warehouse or if it's paused and then resumed. Because if it's paused, it will be probably destroyed behind the scenes and go back to that pool of idle compute. All right, okay. So glad I could answer that question. So let's dive into time travel now. So time travel is a great feature of Snowflake, and it's also your backup mechanism, by the way. So I'll dive deeper into that. So let's say you have your current data storage, and every time you run a query, a history of your table is created. You get a new version of your table, and you can query your old versions. And this is the time travel feature. So you can query all of your previous versions of your table. So it looks a lot like temporal tables in SQL Server, which were introduced in SQL Server 2016, if I'm not mistaken. So it's a bit of the same, logically, it's a bit of the same, behind the scenes, completely different, but you can query your old versions. And it's retained for 1 to 90 days, depending on your license and depending on how you configured it to be. So you don't want on your staging, for example, to retain 90 days because it's truncated and loaded each day. Also keep in mind, this counts for your storage. If you have 1 GB table, and you truncate and load it each day, for 90 days, you will have 90 GB of data. So it counts for your storage, so it costs money as well. So I'll only enable it for tables where you actually need the time travel. After those 90 days, it goes into failsafe, which means you cannot access it. But if something goes wrong, say, oh, I went on holiday before the crisis, of course. I went on holiday for 90 days and you came back, say, oh, I dropped this table and it wasn't supposed to be. Then you can contact Snowflake support and they can access the failsafe for an additional week. If it's a temp table, it's only on the same day, right? So the current data storage, it's a standard SQL, insert, update, delete, select, update. It's the same thing. If you want to query the time travel, you use the add before syntax query. It's basically the same thing, the syntax you use in SQL Server for temporal tables. All right, so and you cannot access the failsafe operation. So let's take a look at some examples of how you would query your time travel. So let's say, okay, I have a table and I know, okay, this morning I did something. Give me the version of the table that was valid at this specific point in time. This is the first. You specify a specific timestamp. Or you say, okay, I did something, oops, I did something wrong. I deleted some data or updated and I forgot the where clause. Just go 5 minutes back. So you can define offset, just go 5 minutes back and give me the data in the table like it was 5 minutes ago. Or if you know a specific statement, again, you can go to the query history and there you can retrieve the unique ID. And you can say, give me the version of the table right before I ran this data. So this is very fucked up. Say, okay, oops, this was an update without a where class. I know the ID of the statement. Just paste it over here and give me, again, all of my data before I messed it up with this update statement. And I can use it to sort of restore your table. This is what I mean with, this is the backup mechanism of Snowflake, because there are no backups. There's no automatic backup mechanism that takes backups of your warehouse. You have to do this yourself. And probably if you want backups in another data center, another part of the world, another medium or whatever, how you take your backups, then you can just, okay, just dump all of your data in blob storage and then copy it to the location you want to be. But you have to do is you have to set it up yourself. There's no automated mechanism for you, right? There's also the undrop statement. So let's say you drop the database or schema or table and say, oh, this shouldn't be dropped. You can just undrop it again, and it will just contain the data right before the point in time you dropped it. Another feature is zero copy cloning. It's a bit like database snapshots in SQL Server, except that here you can also modify the snapshot and then you have the source and the snapshot, the clone, and both are independent. But it's zero copy because it just takes pointers. So it's a metadata only operation. So you have your source, a database or a table, say, okay, I create a clone of this database and I create all of these pointers. So just metadata only, it will not copy data around. But once you start doing updates, deletes, inserts on that clone, it will only keep track of those changes. All right, so you can, for example, say, create this database and clone from this other database, and there you can also use the time travel syntax. So give me the whole database as it was 5 days ago, for example. All right, so let's take a look at some demo in time travel. Sorry, we go over here. So make sure I use the correct database. I'm gonna drop this table over here, and then I'm gonna just create a very simple table containing one string column, right? So, and if you're wondering, yes, I created the DBO schema in Snowflake, so just so I could easily export queries to SQL Server and back. All right, so I just insert two records, hello world. So if I execute my select star, I just get 2 rows returned. All right. Now I insert some other sample data. Again, this is a test, 2 extra rows. Select the data, and I get 4 rows. So now I have to go to my query history. And let's take this one. I take the query ID, I go back to my worksheet, I paste it over here. And now I get nothing. So this is the version of the table that was created, but I didn't insert any data yet. So if I would take another one, I think, for example, this one, I should get the version where there are only 2 rows in the table instead of 4. Here we go. All right. I can also say, okay, just go back a specific amount of time. So this is with the offset function. So in this case, I will go back 60 seconds in time. And in this case, again, the version where there are only 2 rows. If I go back too much in time, so let's say I go 10 minutes back, you will get an error because I recreated the table. So 10 minutes ago, the current table didn't exist yet, so you get an error. Does it survive truncate? So this is always the myth. Ooh, what does truncate table do with your table? Does it break transactions or stuff like that? So you can just truncate the table, and if I take the same ID over here, I copy paste it, I run this statement. Yes, it survives truncate table. So again, it's just the same as in SQL Server. It's a metadata only operation, but it keeps all the older versions. So yeah, I have my time travel intact. So since I truncated the table, I'm just going to reinsert some data. So now I again have 2 rows. Now, a truncated table, what happens if I drop the table? So I do a drop table if exists. So big fan of this if exists syntax that I have in Snowflake, and you also have create or replace, which is a bit more destructive. So I drop the table, and again, Now it doesn't exist anymore, so there's no time travel. They have this like show tables history. Oh, yeah. Drop this, and then you can see all of the tables in this database. And here I can see, where is it? If it has been dropped. So here I can see, okay, yes, the table has been dropped. And there are actually 2 dates of today. The first one was at the beginning of the demo when I recreated the table, and the second one was when I actually specifically dropped the table. So that's why you can see for the same table, 2 entries in this system view. It's called like that. All right, so if I do undrop table, it will take the latest of those 2 tables, and it will just restore the latest version of that table. So if I just query the data again, I will get my latest inserted data from my table. And if I copy paste the ID again over here, I get my original rows again. So the time, if you drop a table and then undrop it, the entire version history is restored again for that specific table. All right, now let's take a quick look into cloning. So here I'm going to say create replace database Stack Overflow clone by cloning the Stack Overflow database, which is a couple of 100 gigabytes in size. It will not be instantaneously. It has to do some checks if it can actually clone the database or not. And then, of course, it has to create all of those pointers for all of the objects inside the Stack Overflow database. But even then, it should take less than a minute. So now we'll play the waiting game. And so this is a good feature. For example, you have a production database, and at some point in time, let's say now we want to have some useful data in development for testing. You can just clone the entire database to dev or test, so you have up-to-date data. It just takes, like I said, half a minute to clone your database, or you can clone specific tables from production to dev. As okay, I want to have now recent data for that specific table. Just clone that table from production to dev, or other way around. No, don't advise to do that one. But it's a useful feature, especially if something goes wrong. For example, if development only runs when you actually try to run it and it breaks, but production runs great every day, nice incremental load, then you can say, okay, just give me the data of production, clone a table, and then I can restart my development with some fresh slate. All right, so this was time travel. Are there any questions about time travel?
No, mostly just comments that it looks like an awesome feature, and quite a few people are enjoying your presentation.
All right.
I'm
Great.
myself, I'm just in awe of the ability to go back in time without actually having to restore a database. Just look what a table looked like a couple of minutes or hours ago. It's amazing.
I know some DBAs will say, oh no, there's no backups in Snowflake, bad. But yes, they're right, they're absolutely right. And then if your whole database, if Snowflake for some reason goes completely corrupt, yeah, then you're a bit screwed because they handle all of your data and they handle all of the versions. But if something goes wrong, just doing that one table restore, it should much faster in Snowflake. So it has its advantages and disadvantages at the same time. Just saying, in SQL Server you have temporal tables, but they're more like, it audits all of the changes on that table. And the advantage of temporal tables in SQL Server is there it can go on indefinitely, while time travel is limited to 90 days. So in SQL Server, you have the advantage. So if you want to keep track of all of the changes ever done on this table, then SQL Server has a bit of the upper advantage here.
But they're 2 different use cases. I mean, for looking at historical changes like auditing or disaster recovery, 90 days is pretty good as things go. From a developer perspective, I'm not a DBA. But yeah.
All right. So here I took a marketing slide of Snowflake, which is the modern data warehouse. And you have some sources coming in, and then you have a ETL, ELT, the streaming data pipeline, whatever the cool kids call it nowadays. A layer that gets data from the sources and puts it into Snowflake, and then you have Snowflake itself as your enterprise data warehouse, and then you have end users and tooling that take advantage of this data in the data warehouse. And I just put on some tools that you can use to recreate this architecture. So typically what I would do is put in a layer of Azure Blob Storage or Azure Data Lake before Snowflake as sort of a staging layer. And then you can just drop all of your sources, all of this data on Azure Blob Storage. There are a couple of reasons for this. One reason is Azure Data Factory currently does not have a Snowflake sync source or connector. There are workarounds, but I think the easiest way to go is just with Azure Data Factory, read your source, dump it on Azure Blob Storage, and then you schedule some SQL statement, just pull this data from Blob Storage into Snowflake, and that goes really, really fast. There's also a Kafka connector. You can also use external tables, which is a bit like Polybase in Azure SQL Data Warehouse, where it's okay, we have a table defined outside of my data warehouse. Personally, I have not used this. And there's also a feature called Snowpipe, which is sort of a streaming feature. I know some colleagues of mine have tested it out. They were not really too thrilled about this feature. It didn't always perform that good, or it was a bit buggy, it missed some data. So if you want to have some streaming data, I would suggest you check out the Kafka or the Python connector, or even the .NET connector for Snowflake, or just drop it on Blob Storage in tiny little files, and then you schedule like every minute or so a copy into that just pulls all of these files directly into Snowflake. This is one option that you can do. All right, and then again for your BI analytics, Power BI integrates with Snowflake. Any BI tool, by the way, should integrate with Snowflake. There are also ODBC connectors and everything available. To give to external parties data, you can data unload. You say, okay, you just go the other way around. Instead of from Blob Storage to Snowflake, you can do the other way around to just push data to Blob Storage. But there's also a feature called data sharing, where the data remains in your Snowflake account, but another party, which also has a Snowflake account, can access the data, and they use their compute to run queries on your data. So this is, for example, the use case, which I often see is I collect hospital data and medical data and aggregate it, and I sell it to other companies. This is a use case where data sharing would be so you don't have to actually send the data to your clients. It remains your property, and they can query it. Of course, you have to set up permissions and everything, but they can query it, and they have to pay their own compute. So this is, for that use case, data sharing is a very great feature. Again, to set up your test and dev environments, you can use cloning. And for data science, there's a whole Python API available. There's also .NET connector available for Snowflake. So I mentioned the copy into SQL statement. This is used to pull external data into a destination in Snowflake as stage. So let's go over this statement. So first, you have to define a stage. So it's with the @ sign and then the name of the stage. And this can be anything. Most likely, it will be an Azure Blob Storage container. And when you create this stage, you have to say, okay, this is my my access key and my token to access this particular blob container. And once you have configured the stage, you can just, okay, with the copy into, you can pull in the files that are located in this blob container. You can also just write a select star from this stage. You can do that as well. And then you have to specify a file format. So, okay, the files I want to read, it's either XML or JSON, Avro, Parquet, or CSV. And you can define the format up front. So if you want to reuse it over multiple copy intos, or you can just define it in the SQL statement itself. The syntax that you see here is when you define it up front. In this case, it's a CSV, comma delimiter, there's a header present, and it's enclosed in quotes if there are any strings. You can also define a regex pattern. Say, okay, only read files if they are gzipped, or any regex pattern will suffice. Purge means if the file was successfully read, then delete it from the blob container. So if you want to archive that file, you probably don't want to set purge to true, but you can purge it. You can set archiving on the blob container itself, so it keeps track of all the versions. If there's an error, you can say, okay, skip the file, but there are other options available as well, like say, okay, just continue, just skip the line, stuff like that. Dump all of the error lines in another table. There are some various options that you can do. So it can also detect if files have already been loaded. So if you don't purge the files and the file just remains in the blob container, it will say, oh, I've already read this file. If it has been reloaded, it will use metadata to detect, okay, it has been changed since the last time I read it, and it will still load the file. But if it's the same file as the previous run, it will just skip the file. And it will keep track, okay, which files I have already read into this table. There's also an option to disable this. It loads data in parallel, and the ideal file size is somewhere between 10 megabytes, 100 megabytes compressed. So your gzip file should be somewhere between those two numbers. Uncompressed, it can be much larger. And I have to say the copy into performance is really quite well. So you can read lots of files in parallel very fast into Snowflake. It supports a wide array of formats. And as I mentioned, you can write sort of a SQL statement. So you can say, okay, copy into from, and then you do a select star or star from this file. And then you can specify specific column. Let's say you have a 100 column CSV file, but you only need the 5 first columns. You just say, okay, just read column 1, 2, 3, 4, and 5. There's also limited SQL functionality. You can check for null values, for example, or you can trim columns. So if you want to do a little bit of data manipulation before it arrives in Snowflake, you can write this sort of SQL statement. And again, you can also just reverse it. So instead of getting data from a stage and put it in Snowflake, you can take data from Snowflake and put it on the blob container. All right, Azure Data Factory. So the current state of affairs, if you use an ODBC connector, I completely misspelled that one. You can use it. There's one available for Snowflake, but you need to host it yourself in a self-hosted integration runtime on premises. So this breaks a little bit of the premise of, okay, it's all in the cloud. So Azure Data Factory is in the cloud, Snowflake is in the cloud, but your ETL will be on premises. So I'm not really fond of this scenario. Another option is that you say, if you really want to use Azure Data Factory for everything, it's okay. You have Azure Data Factory, you can build an Azure function where you just send your SQL statements to, and then that Azure function will just, okay, send that SQL statement to Snowflake and return the results. And in this case, everything remains in the cloud. And I will show you how you can create such an Azure function. But as I mentioned, I think the way to go is probably just use Azure Data Factory, get all of your source data, dump it in Azure Blob Storage, and then maybe with that Azure function, you can just schedule all of those copy into statements and so on and so on. But you can also just use integration services if you really want to. So here is a screenshot of where I use those Azure functions, and you get the actual row count back from that Azure function. Okay. When the data is finally in Snowflake, you can just access it using Power BI, for example, and Power BI luckily has a Snowflake connector. You can see it over there. So you can just import data from Snowflake into Power BI and then build your semantic model in Power BI itself, which is probably not ideal if you actually have terabyte or petabytes of data. In that case, you can just use the direct query option. All right, let's do a demo. So here I have Visual Studio, and on GitHub, you can find some code to create your own Snowflake client using the .NET connector for Snowflake. So here it says, okay, this Snowflake client has a connection string. And here we have a function that will execute a query. Use the connection string, opens the connection, you create a command. And then, and this is a little bit particular for Snowflake, or peculiar for Snowflake. It doesn't execute. If you have multiple statements and you send them at once, it will say, oh no, those are multiple SQL statements. I cannot handle this. This is something weird with the Snowflake driver. Just the way how it is. It's even in the user interface. If you use dbeaver, you get the same issue. If you execute multiple statements, those tools must be able to actually just loop over the statements and execute them one by one. So for the user, it will look like executing multiple statements at the same time, while in reality, it's just executing them one by one. And for example, we used the ETL tool Pentaho at the client. There you had to explicitly say, okay, do not send this as one statement, but send this as separate statements. So it's possible in your ETL tool that you have to take into account, do not execute multiple statements at the same time. So this is why there is this for each loop here that will actually loop over all of the commands in the statements and then execute them one by one. All right. So this is executing a statement. Okay, here we import a lot of libraries. And then we say, okay, we get an HTTP request. So this Azure function will be triggered by an HTTP request. I have a configuration file, this local settings.json file, which contains the connection information to Snowflake. Good to know is when you deploy your Azure function to Azure, it will not include these local settings. So you have to reconfigure yourself in Azure, in the portal. Also, it's a good idea to not include this file in your Git repository, otherwise it will be published to GitHub or whatever. So this is not what you want. So keep it out of source control and it's not deployed to Azure as well. So here I will read my connection string and say, okay, this is my connection string from this settings file. I created one of those new clients. And now I create a stream reader. The result will be JSON, create my statements, and it will just send those statements to Snowflake. It will wait, and then it will return the row count in like, what is it? An HTTP status code. Okay, I don't remember what is the status code for it, like 200 or 100 for HTTP. Say, okay, it was successful, and this is the row count. So if we would take a look at Azure Data Factory, this is a pipeline where I use this Azure function. So I go to here, and I go to this specific function. So I'll link to my Azure function. So you have to create a linked service. And you say, okay, this is my function. I'm going to do a post. Just going to zoom a little bit. And this is the query that I want to send to Snowflake. And here I do the same thing. And now I have a different query saying, now I do a copy into of this query. So if I were to run this, but it would take some time, more than a minute, you will get the screenshot that I showed here earlier. So you get this output, say, with a row count from how long, from how many rows were affected by this copy into statement. All right. Let's see, I think I forgot to open Power BI. Do I have it here? Somewhere, I think I have somewhere a Power BI model. If I go to community, and I think it was Data Grillen where I showed this. Nope, forgot where I put my Power BI model. So anyway, it's very easy. Just go to Power BI, get the Snowflake connector. I'll just open a new one so you can see it. It always.
Good old loading Power BI.
Now I'm wondering where I did put my model. But, so let's say we go get data. And then database, and then it should be over here. And then here I could say this is the server. You have to specify a warehouse, otherwise there's no compute that is running. So you have to specify, okay, this is a warehouse. If I use Power BI, you have to use this specific warehouse for for compute, and then some extra. And then you can choose between import and dire query. And then just click OK. And until you get a prompt saying, okay, how do you want to connect? Do you want to use Azure Active Directory? Do you want to just use username and password and everything? Good to know is, so Azure Active Directory is supported for Snowflake, but you can just use username and passwords, but you can also configure multi-factor authentication as well. All right, so back to the slides. Any questions on like loading data into Snowflake?
We had a straggler question from Eugene. He says, question for Koen, unless he covered it earlier. Did you need easily partitionable data to take advantage of Snowflake? It seems like that's the case for Azure Data Warehouse, for instance.
No, it's not really a prerequisite. Of course, queries will be faster if it's somewhat partitionable, but again, you don't have any influence on this. So it doesn't really matter. You just load the data in the table, and again, try to model it as a star schema, and normally performance will be okay out of the box.
That's what I have.
All right.
So people are very quiet and paying attention.
All right, great. So we're almost on the 1 hour mark. So let's share a little bit about the cool stuff of Snowflake. All right, so I already covered a couple of features that I think are pretty cool, like warehouses, time travel, and the zero copy cloning. But again, and this is one of my personal favorites, is aliasing everything. So for example, I'll write this lengthy expression or somewhat lengthy expression, and I can just take it alias where the expression is test, and I can immediately in the same select statement reuse this alias in another expression. in this case, to define expression first car, which is very great for reusability, because in SQL Server, if you want to do this, you have to create a common table expression and then another one with another query, or just have an inner query and an outer query, just so to reuse expressions, and your code gets lengthy quite fast. Well, here your code gets more compact, and you can reuse the same alias not only in the select statement but also in the where class, GroupBy, having only with window functions. You have to be a little bit careful because window functions are a little bit special. Then I would test to make sure it actually works, or it's possible you get an error as well. I also have to make sure that in this case, test comes before first car, so it needs to be in the same order. If you reuse it, it already has to be defined in the lines above. That's also one of the things you have to take into account. But it's a really useful feature. It makes writing code a bit easier, more compact, and especially if this like really large calculations, and then you have the group by, and you have the same calculations, and then later on you have to change the calculation, but you forget to change it in the group by, and then your query crashes, and yes. So the advantage is here that your code is in one location, and then just reference it. While in SQL Server, it's possible that you have the same calculation on multiple locations, just because you can't reuse the alias. Right. There are also some great SQL syntax. So I think one of the advantages of Snowflake is they are new, they're young. So there are a lot of competitors, Oracle, SQL Server, MySQL out there, which their own SQL dialects, and they could look at them and say, oh yeah, that's a nice function. We're gonna implement that as well. Well, SQL Server and Microsoft has been a bit slow at adapting some ANSI SQL functionality. Snowflake, I think they have a great dialect of SQL. There are already a lot of functions available out of the box. In this case, we have the generator function, which is just generates rows. And in this case, with this syntax, okay, just generate rows for 10 seconds straight. And he arrived at, I'm not sure how many rows there are, but a couple of billion of rows. And this is great if you want to generate a tally table or the numbers table, which is a table that should go 1, 2, 3, 4, 5, and so on. Or you can do it for dates as well. It's a case start with the 1st of January 2020 and the 2nd, and so on and so on. And you would use such a tally table or numbers table to mimic a loop behavior while still programming in a set-based manner. All right. Another function is a split function. I'm not sure if these are already in. I think in the last versions of SQL Server, it's present. But if you have, for example, SQL Server 2012, there's no split function, and you have to create your own split function. Here it's out of the box. Okay, it splits this and it returns the result in an array. So then you have to do some array handling to get all of the individual items. You have list aggregation, which is also available in SQL Server in the latest versions. But again, I think before 2016, it was not present. And you had to use this like dark voodoo XML magic to aggregate all of the values of a column into a single row. So here I have 250 movies, the top 250 movies from IMDb. I just get a list ag, put a comma in between, and then you have a nice list of all of this movie. In SQL Server, in earlier versions, this was much harder to do. All right, again, one of my personal favorites is ANSI SQL syntax. You have a window function like lag over here, and then you can say ignore nulls, right? In SQL Server lag, it will just go to the previous row. It doesn't care if there's a null value or not. And ANSI SQL, you can say, if the previous row is a null value, then skip it and go to the next row until they find a value that is not null. And in SQL Server, we don't have this. If you want this functionality, and Itzik Ben-Gan has written, of course, who else, a very good article how you can do this. But again, it's multiple steps, lots of window functions to get this done. Well, here are just 2 keywords that you specify after your window function. So it makes your life so much easier. And in the example, in the screenshot here, you can see, so -10 goes over here and 25 goes over there. And all those null values, you can't see them, it's just 20, and then the 20 is repeated. And it makes your life as a SQL developer a lot easier. I already showed this in the demos. You have the query history, so you can just look at the queries that you've run. You can click on the query ID, it will take you. You can see the query plan as well, which is not as good as in SQL Server. And you can also see the result set from that query. So you can also go back and check out, okay, I ran some query yesterday. What was the result again? Export the results into Excel and then do some debugging on it. I've also explained the result set cache. If you run the same query twice, it will just come from cache and won't consume any resources. So 2 remarks, you cannot see the result sets of other users. I'm not even sure if, so you have the account admin, this is the highest level of permissions. I'm not even sure if they can see the result set of other users. So it's shielded. So if I can see the queries of other users, if I go to history, I can see the queries that were running, but I cannot see the result sets. So, and the second one, yeah, the result set cache, you can take advantage of this. So I know there are some companies that use Snowflake and they have like a fixed set of reporting. So without parameters, always the same report, always the same table, always the same. And just in the morning, they just run all of those reports, all of the SQL queries, all of the results are in cache. They just disable the warehouse. And every time in the day, when someone runs the report, it runs the same SQL query, which is already in cache. And they will just get the query for free. So run once, pay once, and get query results as many times as you want. But alas, Snowflake realized this, and now if you go above some limit, then you also have to pay for this result set cache. But if you, for normal usage, so just users and then users querying and they have some reports, if it's just normal usage, you will get this result set cache for free. But if you really take advantage of it or profit from it, then it's possible you have to pay for this. All right. Let's take a look at some of this cool stuff. Wrong browser window. All right, so I'm going to use this table, and now I showed already how the non-previous work. So we have get DDL. So here you cannot in Management Studio right-click create table as a script. It doesn't exist over here. Here you need to use the get DDL function, and it will just give you the create whatever table, schema, view to create the object where you use this function to. And if you use a schema or database, it just script out all of the objects inside that schema and database. And so, for example, if I click on here, you can see all of the create table statements from that database. And you can use this to create your own schema compare if you really want to. Right. So now I'm going to switch my role to account admin and do like internal Snowflake schema. And here you can see that you can actually query the history. So you have the user interface that I showed you, but you can also just query this using SQL. And then you can say, oh, give me all of the SQL statement that this user has been running for the past couple of weeks. Or I've used this, for example, if the ETL crashes. Say, okay, give me all of the SQL statements that go to this specific table so I can see what is going on. So this is the use case that it uses. And here you can go really far back in time, while with the user interface, it's usually just limited to a couple of hours or a couple of days. And here you can just query everything. You can filter on the database, on the username, on the SQL statement itself. So it's really easy to find SQL statements. So if you accidentally delete, close all your windows, oh, I forgot to save the SQL statement, you can easily find it in the history, a lot easier than in SQL Server. All right. Another one is ILike. Which is it's a case insensitive like, because SQL Server by default is case insensitive, but Snowflake by default is case sensitive. And I've encountered many bugs because I forgot that Snowflake was case sensitive. So let's create a table where I insert 3 strings with some various casings. And if you would just use the normal like statement, it will only return 1 row. Now, if I would use ILike, then I get all of the rows. So this just makes like case insensitive. And this is useful, for example, if you're writing some ETL code and you have to say, okay, give me everything where it starts with Belgium, and it works when you develop it. But of course, after 3 months in production, someone writes Belgium without a capital B, and then this row is discarded, and then suddenly your reports are complaining that data is missing. If you use ILike, you don't have this issue. You can just write Belgium how you want it with whatever casing, and it will always work. Right. Ratio to report is like sugar candy window function. It just replaces this type of window function. All right, I've written a blog post about it on my blog. So on my blog, I have a whole series of like cool stuff in Snowflake. I think I'm to 11 or 12 posts. So you can check out my blog for more detail of everything that I'm showing here. You can also query your own result sets. So not only the history, but also the result sets from the SQL statement. So let's say I run this statement, and then I'll run another statement, and yet another statement. I think if I go back -3, we can say, okay, select everything from this result scan, and now it returns like this statement over here. So this is useful for debugging. You run a statement, and then you can just see the results, and instead of just exporting the results to Excel and do all your debugging over there, you can just say, okay, select star from my previous result, and you can filter there, and you can easily search between your result sets. Okay, this one I added yesterday. It's a feature that I discovered a couple of weeks ago, and I'm very, very happy that I found it. It's the not distinct from clause. So it checks for null values for you. So let's say I just create a new table, and I insert some data, and I have 2 strings and 1 null value. So if I would take a look at the data, you will see over here, okay, I got my 2 strings and null value. And of course, everyone knows, or hopefully knows, if you check against null using just standard comparison, you will not get any results because the result is unknown. It's not neither true or false, so you get no results at all. So also, if we just check for this specific string, again, the null value is discarded because the result is unknown. Now, let's say you write some ETL and you say, okay, give me everything different from this, or you use it in a join clause. And of course, like myself, I've done so many times, you forget to check for null values, and suddenly you don't have as many rows. Oh, why are there some rows missing? Ah, yes, null values. And instead of just rewriting everything with if null around every possible column, and just if it's null, then replace it with an empty string, you can just use is distinct from, and it solves all your problems for you. So you can use it in a where clause or in a join clause. And I think my new best practice is, instead of just say column A equals column B, always use is not distinct from, that's equal to, or is distinct from when it has to be different, and it will automatically check for null values for you. So this is more compact, saves you a lot of time, saves a lot of time from debugging. So what is going on now? Ah, yes, null values. Now, while I was in this demo, I saw that I forgot to do a little demo about copying data into Snowflake. So I'll just, if there are no questions on the cool stuff, I will just continue with this demo, and then we can wrap up the slides. Is that okay?
Yeah, absolutely.
All right, so just gonna show you how I imported all of that Stack Overflow data into Snowflake, so you can download all of the Stack Overflow files. So don't use the Brent Ozer post, because it will just give you a backup of the Snowflake database in SQL Server, which of course will not work in Snowflake. But you can actually download the actual source data from the site, the open source site, as a zipped XML files. The problem is they're zipped in a format that Snowflake doesn't understand, so you have to unzip it and then zip it again using gzip or another format. And then I uploaded everything to Azure Data Lake, Azure Blob Storage. So here I can see all of those zipped files, and you can see some of them are actually quite big. So I have a 5 gig zipped file, so this is compressed. I have a 30 gig file, so some of them are quite big, and some of them are a bit smaller. So they're here sitting in my Azure Blob Storage. All right. So I'm just going to create a staging table. And if you want to import XML data, the best practice is just create a variant column, so a column that can store everything. Just import it first, just as is, and then you shred it later on into another table. So I'm just going to run this statement, because it's going to run for like 50 seconds. And now I'm going to explain the statement while it is running. So I have my copy into, this is my stage, and this is the file. And here I say, okay, my type is XML. Just gonna change color. So, and I'm gonna say also strip the outer element. Now, why do I need to do this? So strip outer element means get rid of the root node of your XML, and then each specific node of the XML, put it as a separate row inside my destination table. And you need to do this because there's a limit on how much XML can be put inside a single row. And I put it in the comments. This is 16 megabyte limit per row. Now, since I have XML files which are much bigger than 60 megabyte, it's not feasible to just put the entire XML file into one single row. So you need to shred it and put each node of the XML into a separate row of the table. And this is what the strip outer element does. So you can see after 50 seconds, he has finished. I've read in 50 seconds a compressed XML file. I've read about 5 million rows, and it's now sitting in that table. And if I would just take a peek at the first 10 rows, you can see that he has actually created a new row for every node of my XML file. Okay, it's not the most sexy XML data, it's just a creation date, an ID, a link type ID, post ID, and a related post ID. It's just like sort of a bridge table in Stack Overflow that is used to link different posts together, right? Now I'm going to create another staging database with the actual columns. So here you see the same columns from the XML file. And now I'm going to shred this 5 million rows, and I'm just going to do some type conversion on the fly. And now you see in 3 seconds, using a small warehouse, I've processed this 5 million rows and put it into a table as a normal relational table. So again, as I say, out of the box performance is quite great in Snowflake. So the most of the time will be spent on importing the data from Azure Blob Storage and then doing this strip outer element. It will take most of the time, but once the data is in Snowflake, shredding the XML is usually quite fast. All right. Are there any questions on this last part?
On a personal note, the what was it? Ignore nulls. It does things for me. I'm gonna miss that when I go back to SQL Server in a couple of weeks. Sure. Eugene adds, where was that? I'm getting all the idea of trying to turn Snowflake into a sneaky caching server is fascinating. I can only agree, but no real questions actually. All
right. So I'll just continue with the conclusion. So Snowflake versus traditional data warehouse, again, a marketing slide. So typically your demand goes up and down with the month end closing. You typically have lots of users running lots of reports, or when sales have to finish up their quarterly reports, again, lots of usage, while during the month, maybe it goes a little bit over. And traditional databases are more inflexible. Typically in the old days on premises, yes, okay, oh, we need a data warehouse server. Someone provisions it, probably over-dimensioned or under-dimensioned, one of those. I've seen both. I've seen beasts of server and like for like 1 gigabyte of data, and like, okay, you paid way too much. And especially if you know that SQL Server licensing is tied to your CPU core count, it can be very expensive. But I've also seen the other way around, where I've seen like, oh my God, you're running a data warehouse on this server and my laptop is much faster than this server. It has only like 8 gigs of RAM. It has like normal CPU, like, okay, maybe you need to add some RAM and stuff like that. So I've seen both sides, and both are inflexible, because if you're sitting with that server, either you have to like, okay, provision new virtual machine, you need to have a big virtual machine ready, or you need to buy a new server. In the cloud, in Azure SQL Data Warehouse or Azure SQL DB, it's more flexible, but it's still not as fast as Snowflake when it comes to scaling up and scaling down. All right, so again, this is one of the biggest advantages of Snowflake, that it scales so fast in each direction. And you pay only for what you're using, which is true, but don't forget, compute can get expensive very fast. So my main point is, this is Snowflake. Snowflake is an out-of-the-box product. Everything is done for you, and you don't have many options. Now you can put the guy out of the car and you can put him back, but that's about it. And you can push it. You can push it hard and you can push it not so hard, but that's about it that you can do. While on the other hand, tools like NetData or Azure SQL Data Warehouse, like the competitors, they're more like Lego. So if you don't really know what you're doing, you might end up with this, not as fast, costs a lot of money, but it's not that good. While if you really know what you're doing, and if you use Azure SQL Data Warehouse and you know how to cluster everything and partition everything and do everything right, then it can be really, really fast. While Snowflake is fast out of the box, they don't have that many options to drive up performance. Some disadvantages of Snowflake: it's still a very young product. So the community has to grow. And if you compare it with the SQL Server community, it's like night and day. Like there's no comparison with the Microsoft Data Platform community. We have a case in point, so many virtual conferences. We have, or last year, we had lots of in-person conferences. We have so many people writing blog posts, writing articles, creating YouTube videos, helping people all around the globe. While in Snowflake, it's there, but it's just not as big. There are forums, there are some people answering questions on forums, but just not the same scale. So it still has to grow a lot. There are a few bugs here and there. They are getting fixed, and support has been very helpful in the few occasions that I had to contact them. They're really helpful. A very big disadvantage of such a young tool is that there are less tools available. For SQL Server, you have everything. You have like Apex SQL, you have Idera, you have Redgate with all of their awesome tools. While for Snowflake, it's much, much less. There's no schema compare, at least that I checked. While for SQL Server, you have like the Redgate tools, of course, but even Visual Studio, SQL Server data tools is free, and you have a schema compare. For Snowflake, this is not available for the moment. There are some available somewhere like in the dark corners of the web. You can find some open source tool where everything is command line and like, but easy to use with great user interface tools. I haven't seen them yet. And this is for schema compare, but also for source control and other stuff. So all the DevOps part is much harder to do with Snowflake because there are no tools available. I mentioned this a couple of times. There are almost no tuning options. Sometimes you have a query, it runs fine, and the day after it runs for hours. And remember, if it runs for hours, you're paying a lot of money, and you don't really know why. So in this case, we had a very big data vault query, and when one of the tables was empty, it was really slow. When there was millions of rows in it, it was very fast. So, and then you're like, we have no idea why. And you can go to the query plan, and you can see, oh, I think at this point, it really starts spilling to disk, but you have no idea why. The only thing you can do is contact support, and they will try to figure out with you, okay, why is this? And they can suggest some improvements. But most of the time, just okay, try to rewrite your query or just split it up and use temporal tables or something in between to just store intermediate results. And when the plans are a bit smaller, then everything goes fast again. When I started out with Snowflake, a good 2 years ago, I had the impression that role management, so security, defining roles, defining users, what the roles could do was really hard. But in the meantime, they have been adding some user interface options. But even then, I still think it's still not as intuitive as it is in SQL Server. I think there are also some feature like, if you say, okay, you have read permissions, but if you add new tables, it's not automatically that the new tables, that you also have read permission on those new tables. You need to do something special with it. So this is like, it's not as intuitive as I would like it to be. I'm gonna repeat it, keep an eye on the cost. Storage is probably not a big problem, but compute, if you have like one of those users using Tableau and they do a mashup and you have like these raw queries that are being generated and say, oh, it seems that it's running a bit long. I'm just gonna leave it running, going home, and I will check in the morning if the query is finished. These types of queries can cost you a lot of money. If you have a warehouse running for 12 hours straight, it can cost you a lot of money. So keep an eye on cost. Cost management becomes more important. And is not just, okay, we scale down our warehouses. For example, we have a couple of warehouses running and not that big. That's okay. So you have, you can do a little bit of load balancing and lots of concurrent. But we saw, okay, most of them are not using very compute intensive queries. So a lot of their warehousing were maybe operating at 20% of their capacity. And I'm like, oh, but it doesn't matter how much capacity the warehouse uses. If it runs, you pay. If it is it at 100% or the 1%, it doesn't matter. You pay for the seconds it is running. So in that case, we had to consolidate a couple of warehouses into one warehouse, same size. So we went from 5 small warehouses to one warehouse, but that one warehouse could handle all of the queries. And then you have reduced your costs 5 times. So this is something you have to keep in mind. And using Snowflake has enough metadata that you can query to find out what are the problem warehouses, what are the problem queries, which queries are running long. So you can do some investigation, so do some cost savings. All right, so this was my last slide.
Which times perfectly because we're kind of running short on time, so I was just about to cut you off.
All right. Okay, if there are any questions or remarks, now is the time.
Mostly, yeah, exactly. Now is the time. Mostly comments that the people enjoyed your session. I, for one, enjoyed your session very much, and I'm going to I'm going to rewatch this in my own time when it's not inappropriate for me to just look away and take notes.
Okay.
But there were some great things shown, and I appreciate it a lot. So thank you so much for speaking.
No problem. I see that there was a question about, are there any ingress costs for uploading a stream data for Snowflake? Well, yes. So Snowflake manages everything for you. And I forgot to mention this because you cannot find it in the Azure portal. You have to go to the Snowflake website and they will set up everything for you. And everything what goes on inside Snowflake, that's their problem. They will pay all of the cost for storage and ingress egress. It's their problem. You just pay the credits for the warehouse consumption and the storage of cost, of course, of all those terabytes. But if you stage data on your own data lake or your own blob search and then pull it into Snowflake, yeah, that will probably incur costs as well. I'm not really an expert on this because when I worked with Snowflake, I was more in the developer part of things. So I worked with Snowflake extensively, writing SQL, data modeling, stuff like that. But the whole administration part, was other people were responsible for that part. And so I didn't have that many experience with it. All right.